Hey, what's up guys? Welcome to a new tutorial. Today we're going to show you how to program the X52 Pro joystick, both the lights at the joystick as well as the MFD on the joystick. So, the way we'll do this is we will the API is written in C. So you will get a DLL and a header file, which are shipped with the driver. But what you don't get is a lib file. So I created a lib file for this, which by the way is 64-bit only, at least mine. You can create the lib file from the DirectOutput.dll by yourself. Just look it up, create lib from DLL. It's not very complicated. And you also could use the DLL for itself without a lib file, but it is a little bit more complicated. And I think just using the lib file and getting the lib file provided with this is a really good way. So I'll provide you the include directory, the lib directory, and these three HTML files and the DirectOutput.dll. You can also get these with just the normal driver shipped. And yeah, so what these DirectOutput.htm and X52 Pro.htm look like is this one. So it's basically a very basic documentation of how the whole SDK works. So we get here our functions, and then we see here like this is the initialize and what it also has to do. So this is the one for the X52 Pro. So first, let's set up our project. So we start with an empty project, and then we have to go into Project, Direct Output Properties, and then you go into C++, General, and Addition Include Directories. And in the Addition Include directory, you put this folder. Then you go to Linker, General, Additional Library Dependencies, and here you put in the lib folder. And then you go into Input, Additional Dependencies, and here you have to put DirectOutput.lib, semicolon. This way you will tell him to use this file. So after that, we're pretty much done. Make sure you are on 64-bit, and you also set this whole thing up in 64-bit, because at least the files that I gave you are only working with 64-bit. So the first thing, as I said, the API is in C, not C++. So when we are writing in C++, we have to write a extern C, and then we can include DirectOutput.h. Very good. So, and then we can look in our documentation. So, the first thing we have to call is the initialize function. As you can see, we have to pass in a constant wchar_t pointer with our name. So, we create a constant wchar_t pointer name, and of course it's not a cost but a const, and it also is a char. So, and then we pass in our name, which we just call test tab. Okay, and then we call direct output and initialize, which should be right there, and we pass in our name. Perfect. So we initialized our plugin. Then the next thing to look up is we have to register a device callback. So when you look at this, we have to pass in a pfn callback, a pointer to a callback function to be called whenever a device is added or removed. So when you look up here, we have here the direct output device callback, which is a function we will have to write. So we can basically just copy this thing and write it above here, and this will give us the appropriate function, which will be called every time a new device is added. So we call DirectOutput register device callback, register device callback. Then we pass in our function, so I pointer and then DirectOutput underscore device callback. So this one, and then we need a context. I don't think it is specified in the API what this context should look like. No, it isn't. So I just give it a basically a void pointer context null pointer, and this works just fine. So just pass in the context here, and you'll be fine. So we have registered our device callback. The next thing we'll have to do is enumerate the devices. So we can just copy this function again. No, wait. We don't copy this function, but we copy the enumerate callback function. We will have to write right there. No, we want this one. Yeah, this will basically give us the enumerate callback. So we call DirectOutput underscore enumerate. Then we pass in our pointer to the function. So DirectOutput, and then our enumerate callback function, and then the pointer to the context. Nice. So this is basically how you initialize the whole thing. Now, we of course, for the next functions, we will need our devices. The way we'll do this is we first will include the vector, and then the next thing we will create a new vector containing void pointers. So these are our devices. And yeah, so, and then we have to use these functions to, in this case, if we edit, of course this is a boolean, here you can basically add the device or remove the device. So push back, and then the device, so H device. Then you could theoretically also remove the device if you want that. And then here we have also device pushback, and then H device. So now we are ready to add a new page. So how the whole thing works is that we have pages, and direct output uses a concept of pages to separate data. Each application can add one or more pages to the device, and each page holds a collection of output settings. The new user navigates between pages with next page and previous page buttons on the device. Okay, so we will have to add a new page. So we will call add page with a void pointer to the device, a dvoid with the page, and a dvoid with flags. And if we want to set this page as active, which we want, we will also have to flag _set_as_active. So we will call, first create a dword with our page, just give it the number 1, and then we have to call DirectOutput_add page, and then we have to call, given the device, assuming that we just have one device connected, we can just use the device at position 0. Then our dword with the page, so page, and the console.wh debug name, we can pass a null pointer here. The debug name is just for debugging purposes. We don't really need this. So and then we set as flag _set as active. Great. So we have added our page. We registered this device callback, enumerated them, initialized the plugin, and now we are really ready to do something cool with our LEDs. So we have to look at the LED, and we see that we have to pass in our device, the page, and a index and a value. So in order to know what these two things mean, we have to go for our datasheet X52 Pro, and we see the LED IDs, and we see that we have 19 LED buttons, IDs, which is significantly more than we have buttons. So the way this works is we have on most of the buttons we have a red component and a green component. And when you turn both on, you get a yellow color. When you turn the red component on and the green off, you get red, and when you turn the green component on and the red off, you also, of course, get green. So we now want to use this button here, and we want to turn this button into first a yellow color. So we call with the ID 1 and set it to 1, and 2 and set it to 1. So direct output and underscore set LED. No. Set LED, and device is 0. Then the page, page. The index, which was 1, and the value was 1. And then we can copy the whole thing, paste it below, and set the second one. In order to the program not to close directly, we will also include IO stream. Make just a new value and std cin x. So we have to just put in a random number, and then the program will continue. And then we also have to call DirectOutput.initialize. Great. So now we can test the program, and what we'll get is a error message. No, we will get no as error message because I tested it before. So, but we also don't see anything. So, the first thing you have to do is you go into your project directory, X54 debug, and you will have to add the DirectOutput.dll here. So just be aware of that you have to. It will give you an error message which says that it can't find the DLL. Just add it to the directory. So, and as we saw last time, the LED does not turn to any color. So we did something wrong, I guess. So let me it's just for let's test it again. Oh, okay. So you don't you are not allowed to pass a null pointer. You will have to pass a some kind of wchar_t pointer into it. So yeah, and now we can also see that the LED turned yellow. So just to show it to you another time, we will set the LED to red after this. So we have to turn off the green component. The red comes first every time. So we have to set 2 and 0, and we will wait for another cin, and we will start our program. So very good, we have our yellow, and then we have our red, and the program closes. So the next thing you of course want to know how to make is how to use the MFD. Now the MFD works in the same way as the LEDs basically, and we get a function here which is called setString. So when you click on this, we see we pass in our device, our page, an index, a CCH value, and another value. When we look, the CCH value is the number of characters in the wchar string data, and the thing we want to show on this display. So what we can do is we add in a new constant wchar_t pointer. No, wait, and we just value, and then we can make it a array by this, and then we can make a so let's just call it test app. This is what will be shown up on the display, and then we will go to our DirectOutput set string, and we'll pass in our device. Device is 0. Then the index will be page, then our index, and then we'll have to go into our reference. Oh, okay, we can see Okay, let's just put it into the middle, so we pass in 1. Then we have to look how many characters do we have. 1, 2, 3, 4, 6, 7, 8 characters, so we pass in our 8. And the pointer, so we pass in our array. Perfect. So now we should be able to see that something on the display. And just to show you, we'll go and yeah, we can see test app, which is exactly what we wanted to have. So great. So now that it all works, this is basically how you can program your X52 Pro. Everything you can configure in the software, and you can go even further with the MFD. And also, if you own a flight instruments panel, you can program it this way. So I hope really I could help you with this, and I hope you enjoyed this tutorial. And I hope that you now learned how you can use this SDK, and I hope that it encourages more people to use the SDK to write all kinds of programs for the various applications, the various applications out there, like flight simulators. I know that there's a program out there for War Thunder, which uses the MFD only, and I know there's a program out there for Elite Dangerous which uses the MFD only. But they're basically very basic programs, and I haven't seen any program so far which uses the LEDs. And of course, there is the official FSX plugin. I think there's also one for the X-Plane, and I think there's also a DirectOutput.lib API, which someone wrote, but I don't think that this is too overcomplicated, and I think it's really doable, especially when you set your a set of new words, like I did a while ago, where you just pass an LED on, LED off, and then you can just like here, you just LED underscore fire a red, and then you pass an LED underscore on, and so on. This makes it a lot easier. Here, it's just like when you can really make this a lot easier, especially when you write a another class which is doing all this stuff for you, and then you just call, okay, set this LED to yellow, to red, to green, and all this kind of stuff. And yeah, I think this is really great, that we are now able, or we were able for a long time, but yeah, I hope I helped you with this, and yeah, I hope you enjoyed this tutorial, and I see you guys next time.